All right. Thank you everyone for coming. This is the Vantage headquarters, Vantage with really and competition platform. We're doing this meetup once every 2 months about, so thank you for making the July version. I know it's super nice outside and a little tempting to stay out there. Chris Bell is our speaker tonight. He's the CTO of a startup called Knock. We met Chris years ago. We worked in the same co-working space. And he's going to give a talk about his first 2 years of infrastructure. Cool.
Thank you for the clap. Yeah. I need that. Like holding the mic always makes me feel like I'm doing a stand-up there, but I promise you there's no jokes in this step. Cool. So I'm here today to give you an infrastructure journey, talking about the first 3 years of our infrastructure and a little bit of architecture of what we do at Knock. So hi everyone, I'm Chris. I'm the CTO and co-founder at Knock. Okay, before we start, show of hands, who's heard about Knock? Our marketing team needs to do that. No, I'm kidding. We're very early, but I'd love to tell you a little bit about what we do as well. And let me get this deck going. Okay, so what we do at Knock is we power notifications for developers. What that means is you might be familiar with companies like Vercel, Webflow, or Amplitude. We power all of their transactional notifications. So think about when you're in their products and there's a little bell icon and something pops into a feed. That's coming from our APIs. So we send a lot of transactional notifications. And we're doing that for about 250 plus companies in production today. And we're at Series A as a company right now. So to give you an idea of stage and where we're at, because I think that's important to frame this whole talk. Cool. So just to give you an idea of how Knock works, because we're all, well, I'm sure there's a lot of engineers in this room, so I think it's important so you understand what we're talking about. So at the core of Knock is a workflow engine. So you can basically design these complex notification flows to say things like, when this happens, send an email out, maybe wait 10 minutes, and then send a push notification if someone hasn't read that email, things like that. You then trigger those with our SDKs, they make API calls, and then we'll deliver those notifications on your behalf to all of these different providers. So I think we support about 35 providers, plus we have a webhook, which is a sales way of saying that we can support anything, right? Then what we can do is also take all of the data that's coming off of all of these providers and basically normalize it and stream it to places like a data warehouse or analytics tooling as well. So like places like Segment, things like that. Cool. So that's Knock in a nutshell. We're going to take an infrastructure journey together. I feel like I have to say that in like a low voice. But I just want to say before we get into the meat of this talk, one thing that's really cool, and if anyone's at a startup today, I basically wrote this talk by remembering what we've done by our changelog. So we're in our 3rd year of our company, and we've shipped a changelog basically weekly for the last 3 years. This is our first one. We're live. Which is kind of a misnomer because it was in private beta and it wasn't really live to anyone. But yeah, it's a really great way to remember like key milestones in your company's history, and I would definitely encourage everyone to do it if you're not doing it already. So let's give you some numbers right now. I put like billions of API requests on the title of this talk, but giving you some real numbers here. So Knock today in June 2024 does, we do about 1.4 billion API requests a month. Our P95 is 25 milliseconds, which we're very proud of. We have about 2 million active socket connections, so a WebSocket connection open to someone at any point in time. We write about nearly 7 billion events a month. And we're a team of 9 engineers, 1 SRE, and me, the CTO. There's also other people at Knock. I'm just thinking about the engineering team in this context. So just to give you an idea of some of the early principles that we were thinking about when we were thinking about like, going from just me thinking about how do we bring this service to life. So I don't like infrastructure, and I don't like managing infrastructure, probably like other people in this room. So my goal was to use as many managed services as possible. Try and outsource the complex operations of doing database backups and running databases at scale and things such like that. But we also wanted to own certain parts of our infrastructure that matter. So I didn't want to think about outsourcing all of our service and running our service to a platform as a service like Heroku or Porter, or name one of those many startups that are in that space right now, Railway and such. We wanted to use what we knew and what we've used before, which most of my experience has been with AWS for the past 14, 15 years. Cloud credits are your friends when you're starting out. I think as an early stage startup, you can get access to $125,000 of cloud credits out of the gates for the first couple of years, which is, I feel like, super beneficial when you're trying things out and seeing what works. We wanted to keep things very simple, but retain optionality for as long as possible. So what does that actually mean in practice? Well, I had this early conceived notion that we would want to run our service on premise or like within someone else's cloud. And I think by virtue of that statement, it means that you have to think about, not being completely wedded to a single cloud service over time, right? So an example is, you buy Lambdas or you run serverless functions, and now like it's very difficult to think about cloud portability, things like that. We'll talk about that a bit more at the end of the talk, but that was one of my early ideas on principles here. Setting ourselves up for the next stage, I think, is really important. And what that meant for us is, like, we knew that we were going to be an enterprise SaaS platform. So we thought about what it would mean to sell to larger customers and what kinds of things we're going to need there. So surprise, surprise, security, compliance, those kinds of ideas become very important at this kind of stage. So we're trying to lay out this blueprint and this foundation for making sure that we could do that. And yeah, above all else, we're trying to balance this time to market with scalability and maintainability concerns. And like that's a very difficult thing to do, right? Like it's very easy to over-engineer at this point, especially when you're in this like, hey, new shiny toys, I want to like build a new service and go from here. So let's talk about our initial architecture in May 2021. So it looks like this. I'm horrible at diagramming, so you're going to get diagrams that look like this all talk. So, it's a pretty standard setup whereby we have an EKS cluster. We are using AWS for hosting. We have a VPC. We use Aurora for our primary data store. We use Mongo for unstructured user data, which for us is things like user properties and data like that. Cloud DNS, Elasticache. We rely on Vercel for our front-end hosting. I'll get into that a bit more. GitHub, Datadog, Sentry, LaunchDarkly, the name of SaaS services adds up very quickly when you're starting out. But I think the point here is that some of our early decisions that we tried to make out of the gate, we like to think about building, to those points before, setting ourselves up for the next stage. So trying to remember things that worked very poorly in the past. So one of my goals was to make sure that we had logically separated AWS accounts. And you may all be taking this for granted right now, but if you've ever worked at a company that has all of your infrastructure in a single AWS account, and then you have to split things apart over time, it's very difficult to do. So we started with those kind of practices from day one, terraformed everything, used Kubernetes as a container runtime, which we could question that choice probably all night. We made sure that we had monitoring, reporting, alerting. And then I think one of the interesting decisions that we made early was the separation of a control and a data plane to think about how we might scale out this service over time. So I'm just going to touch on that a little bit. Oh, and yeah, one of the reasons I can talk about all of these early decisions is not because I have perfect memory. It's because we actually captured them all in what we call decision logs. So we made a decision to log our decisions, which I think is great. And what that does is like basically gives the engineers who are joining the team a place to go and think about like, why did you make that choice? Because inevitably someone's going to join the team and say, why did you pick MongoDB? Which has happened many times. And here's a document for why. So here's a bit more about our applications. So they're split into two: control and switchboard. Clever names, maybe for some. Control is our control plane, where customers will design, build, and basically look at all their notification data that's coming in. The spoiler of this talk is that we use Elixir, if anyone's familiar with Elixir in the crowd. Some? No, very few. Okay. Or we have a really shy audience. Elixir is a functional language that compiles and runs on top of the Erlang virtual machine. It's a highly concurrent, fault-tolerant language. It's got us very far. And then switchboard is like the kind of the meat of the service, and where I'm going to focus most of the kind of infrastructure going on tonight. So switchboard is our API layer, it's our WebSocket layer, it's the part that takes requests and turns them into the notifications that we're going to send to your users or yourself. Mostly in the beginning, it was just Elixir and Postgres, which is a simple choice. And just to give you an idea of what it looked like, we split into three parts. Notification engine, which is like the core workflow engine for us. So the part that takes one of these jobs and basically runs notification workflows and turns them into the notifications to be delivered. Posty, which is, again, I love all the names because I came up with them, but they stuck around. So Posty is the part that will basically deliver the notifications to the end users. And this is how simple things started out. By the way, I'm not saying any of this is right. I like to just frame this in the your mileage may vary. Please don't copy anything that we've done, but this is where we are today. So I wanted to give a bridge inflection points about the journey along the last 3 years to get to that, all those numbers that I shared earlier, because we started out with this architecture and we had a few different what they call design partners, which is like early customers that we're working with to build our service and send real production notifications. After we launched in May 2021, we basically worked with those design partners, building out the core of our service up until a point where we were ready and we felt that the product was fully baked and ready to take to market. So this is the first time that we really considered this notion of scale. And you'll notice that it was like a year, and the architecture didn't really change in that year. We just added features, lots of lines of code, working with customers, like really thinking about like what's the product rather than what are we running on, burning through cloud credits as well. So in March 2022, when we started to think about preparing for scale, one of the first things that we did was actually think about running load tests. So as you might imagine, we were thinking about spiky notification volumes. So what if you're Vercel, one of our larger customers, and they suddenly send us 20,000 deployment failed because a bunch of users did that in a single second. So when we did this, yeah, as you might imagine, the results weren't that great in the beginning. As with all services, they need to mature over time. We need to think about making the service reliable, making sure that we are looking at the choke points and making sure that we're designing for those. So the first thing that we did is we realized that having a Postgres-backed job queue on the critical path was maybe a bit of an error, in the sense that we would basically overload the database if we had a significant number of requests. So our first thought was we wanted a way to buffer inbound requests and absorb spiky load. So what we did there, we basically reached for Kinesis, which maybe goes against some of my early principles about thinking about portability in our design, right? But one of the reasons we reached for Kinesis was its ability to basically reshard on the fly so that we could think about adding new topics and basically making sure that if we had new customers, we could route them to single Kinesis topics and allow us to grow for the future. So again, one of those principles about thinking about the future a bit more. We also leverage something in Elixir called Broadway, which is basically an abstraction across the idea of a system that can pull things off of the queue with back pressure. So Kinesis has an adapter for Elixir called KCL-EX, and that's what we used in the beginning. But our thought process here was that we could retain optionality because Kinesis and Kafka could effectively be swapped out for each other. So, great diagram, Chris, but we just put Kinesis in the middle effectively. So requests came in, they're written to Kinesis. Kinesis then writes it into our notification engine before we queue into the job queue and such. So that definitely helped us getting to the next inflection point of scale. So, you know, fast forward, we've landed some customers, we're growing. One of the bigger features that we added in 2022 was this concept of workflow debugging. I actually have a video. It's my only video. So this is the NOC dashboard, and what you're seeing here is our API logs view. So any API logs that you're sending into NOC, we're recording. Think about Stripe. I'm sure everyone's familiar with dev tools like this. But what we do in addition to that is we record the actual execution steps of a workflow so that you can go in and debug every single part of what's happening for each customer that's receiving a notification. So imagine, like, you know, Ben at Vantage has his notifications turned off for email. So your customer support team can come in and say, why did Ben not receive a notification? They can answer that question very easily. So building this system was a bit of a step change in how we started to think about events in NOC in general. So prior to this, you know, we were ingesting API logs, but we're kind of just like bulk ranking them in memory into a database. So one of our goals here was basically being able to store a high number of these immutable logs, so API logs, workflow run logs, which includes events. And then we wanted to make them accessible to our customers via that dashboard that you just saw in that experience, but also via our API as well. And then in addition, one of our principles as a developer tool is integrating into the broader ecosystem. So think about, like, you want to know how your notification service is performing at scale, right? How many message deliveries are you getting? How many things aren't being delivered? So we actually stream all of that data to places like Datadog, New Relic, and then we can send interaction data down to places like Segment, Rudderstack, and someone else I'm forgetting right now. So our solution here was, spoiler, Kinesis. We actually use a lot of Kinesis at NOC. We like to build on these primitives that we started maturing as part of the infrastructure, right? So we ended up having a Kinesis topic kind of log that we're sending. And then we basically take that, stream metrics to it, batch them up, and then insert them into a database. And this is how we started. Really simple, just relying on the parts of the system that we already had, right? At this point in time, you know, there was 3 engineers on the team. And we had dozens of customers, but not yet hundreds of customers in production. So we're talking about small scale, but thinking about larger scale as we develop. So we leverage a feature in Postgres that you might all be familiar with around partition tables. So it basically allows you to date partition or hash partition a table. And the reason why we looked for that is, number one, it allowed us to age out old data very easily. So we could say, like, we only retain API logs for 3 months, and then we want to drop a whole series of partitions after that date. And it also allowed us to basically make sure that those tables have isolated performance. So you can think about indexes and writes being localized to that table. Beyond that, we then basically added multiple consumers to forward those events to other downstream services like Segment, Datadog, all those places I talked about. And then, you know, Kinesis isn't infallible, and this structure that we implemented wasn't perfect either. So there are cases whereby the writes could fail, or you know, maybe the database is down, or maybe that third-party service is down. So we basically just took a decision to do the easiest thing, which is dump them to a DB, which is good when the database is up, and then replay them over a cron job to make everything very simple as well. So this is kind of what this looked like in the end. Kinesis, we have this dedicated logging service now with different consumers, writing to Aurora in batches. So I'll talk a bit more about this later, but from this point, this was, what did I say, June or something like that, summer of 2022. We replaced this in 2024. So this lasted a really long time and got us very, very far. One of the other coolest things that came out of it at the time was we implemented a system whereby we could actually turn off like these logging consumers via launch darkly feature flags. So the reason why we did that is so that we could degrade our service and basically think about how can we ensure back pressure on the rest of our service and make sure that, you know, if we're getting too many logs and we're actually overloading on the database, how can we degrade that part to make sure that the service stays up? There's a really great blog post written by one of the team, Brent, here, that goes into a lot more detail, but just to give you a rough idea of how this works, the orange circle here, in Elixir is actor-based. So if you're familiar with actor-based models, this represents a process, but you can think about this process as being like the logging service, or maybe API logs, and then another orange circle is our segment writer, something like that. So our feature flags basically allowed us to turn off trees inside of here at runtime, so that we could degrade different parts of the service. So it was a really neat pattern that's actually worked out incredibly well for us as we scaled, and we found other bottlenecks in the service. You can see here, this is a status page screenshot I grabbed when we actually temporarily degraded the performance of our logging services to maintain the stability of the rest of the system. So this, again, one of these patterns that we got a lot of leverage out of, and allowed us to think about, you know, like just having a bit more control and giving us knobs to turn and levers to pull to degrade things. Okay, so November 2022 rolls around and I call this section, oops, we need some data info. So up until this point, we basically had a single BI tool, which was Metabase reading from our read replicas. So, and that's what we used to power all of the like insights that we were looking at internally at NOC at that point. A growing startup with growing usage means that you need to answer questions about those usage, whether it's to investors or internal stakeholders or whatever it might be. In this case, it was my co-founder, Sam, who was like, I really need to understand like, who's using what in our system and how many messages are going out, things like that. What we were finding was querying from the read replicas was causing load on the read replicas that was actually application critical. And to be honest, like, I think it's inevitable that a startup needs to think about data infrastructure as part of their stack. You know, for us, we send a lot of notification data, so PII is very, very important. So we wanted to make sure that only relevant people had access to production data, what's actually there, and what's actually like exposing customer data as well. So there's a really fantastic blog post that's probably wildly out of date now because this is 2 years ago, that is from the Incident.io team about a modern data stack for startups. And this became heavy inspiration for us about the stack that we wanted to produce going forward. So what we effectively did, we spun up a Redshift cluster, dbt for models, Fivetran for an ETL pipeline, Metabase for BI, which we already had, and then we leveraged HighTouch for our reverse ETL. I think one thing to call out here that is interesting, Fivetran quickly became unreasonably expensive for us, and we ended up ripping it out and putting in a fire hose, a Kinesis fire hose to stream events to our Redshift cluster, and we reduced the cost from something like $10,000 a month to about $300 a month. So that was a very non-scalable and bad decision on our part, to be totally honest. But it does run our dbt models for free, effectively, which is great because then we don't have to pay for dbt cloud. Okay, so January 2023 rolls around, and you know, we're tracking along as a startup. We've got some larger customers. We'd actually signed Vercel as one of our larger customers by this point. And I want to talk about some problems that we face. So we had another very large customer going live amongst our other growing usage. And this chart kind of puts into practice what we were seeing, which is what you might call very aggressive garbage collection. But these pods are basically running out of memory and being terminated. And the reason why was not about our notifications that we so diligently load tested. It was actually much more about our real-time socket usage, which was being powered by Elixir and Phoenix as well. We basically, at this point, all of these lines where the coming back up, we were manually rolling deployments like all day. And it was a horrible time in Knox history. We couldn't bring up pods fast enough, and when we did, the traffic would rebalance around the cluster, and then the next pod would die. It was a whole thing. Like any good debugging story, it was a single line that the problem laid in. We were compressing when we shouldn't have been compressing, and that basically caused a large memory leak. But although we fixed the solution, we fixed the problem. The real solution wasn't just that single line of code change. It was really restructuring and thinking about our services for the next phase of growth. So what we ended up doing was thinking about, we have our single monolith, which is switchboard. And what we wanted to do is actually break that apart so that we could scale those individual pieces. You might think about this as like microservices, but I want to show you a small bit of Elixir code that proves otherwise shortly. So what we ended up doing is basically splitting it into an API, a socket layer, so for the real-time sockets, and then our processing layer, which is really just the part that takes all of those notifications, runs them, and delivers them to third parties. And then we directed our A or B to route to the specific services, so our WebSocket to the specific socket service to ensure that, you know, that memory leak wouldn't take down our core services in the future. I don't know who out there has done this, but tuning K8s and all of the kind of readiness and health checks is a real endeavor. And we spent weeks and weeks and weeks like making sure that we had the right configuration, trying things out in production, making sure that we had the right tunable parts of the configuration so that we could do that. We actually ended up, we use LaunchDarkly so heavily now for all of our like dynamic config like that. And it allows us to basically encapsulate like JSON configuration about like in this case, what's the time of readiness check, and to be able to dynamically change that for different pods, things like that. Yeah, and then we just added a ton more kill switches as well, because I think one of the important parts of and important learnings of running an API and a third-party service is that you can't really predict someone's usage of your service ever. We had a bad actor use Vercel's socket to basically send invalid data that was taking down every socket process within our cluster, things like that. So we needed more kill switches, we needed more feature flags to basically say like, terminate the socket connection for these particular customers and such. This is the architecture that we're running with right now in terms of how things are split up. So we have a web layer, our sockets, our processing layer. We actually broke apart our Redis caches. If you remember from the beginning, we had a single Redis cache. We're now running multiple caches, some of them shared. Still got our Postgres back job queue. It's just, yeah, there's so many horror stories about running that. You ask me after. But it's still going strong at this point. And then this is the only Elixir code I'm going to show you all presentation, I promise. But basically what we do in our monolith is we can pass through a deployment role that tells it to start up different different capabilities of our application tree. So in this case, we can say like, are you the API? So if you are, start up the API layer. Otherwise, don't bother starting it. Are you the processing layer? If so, then make sure we're starting up all of those Kinesis consumers and things like that. So it just allows us to have a single container and a single monolith, but actually split it into different services and retain that kind of benefit of operating within a single monolithic environment. Cool. Let's keep fast forwarding through history. We're in November 2023. So I showed you our initial log architecture. In November, we were writing about 1.5 billion rows per month in our log tables. There were certain customers at high volumes that could no longer even load those tables, no matter how many indexes we put, how much tuning we did. Postgres was really struggling at this point. And I think more of the reason why I was invested in this project is our Aurora costs were ballooning. Thank you to Vantage, who was able to surface that for us. And it made it easy to prioritize this kind of project. But we were spending a small fortune in storage and backups because we were basically logging so much data. We, like Vantage before us, I spoke to Brooke about this migration. We selected ClickHouse as our new log store to think about storing and operating on this like large amounts of log data that we'd have. And the reason why we were really interested in ClickHouse as well is not just its capabilities there, but its ability to compress data as well is incredibly good. So there's a few folks who've done this kind of migration, high touch, Cloudflare. Obviously, Cloudflare is a very large scale, and they have a really good blog post about their Postgres to ClickHouse migration as well. We started using ClickHouse Cloud as the hosting provider for ClickHouse, just to, again, follow that principle of managed services as much as possible. And then basically did a classic dual write on the migration, started reading from both sources, identifying issues, slowly migrating over to ClickHouse when we felt like the data was backfilled and we were ready to go. Yeah, this is a fun chart for me because it's a really successful project in Knox history. So we migrated all of our API logs, and it accounts for about 6.85 terabytes of data today. But the compression ratio on it is kind of phenomenal. So it's like, 65 terabytes uncompressed, which I'm always blown away by. All of our logs now work, which is a real benefit in running a service and making sure your product actually works for your customers. And then the hypothesis about the cost being tied to Aurora was proved true. We're able to reduce the cost by about 80% just running a ClickHouse cluster. And it's like barely doing anything, honestly. So we've got a lot of headroom in that service right now. So we're still doing this migration. This was the first phase of it. We've got other logging tables that we're trying to migrate over time. So yeah, this has definitely been a long running kind of process for us. We're going to have a blog post coming out in a couple of weeks about the lessons learned about ClickHouse as a log store. That if you're embarking on this project, the engineer who led this said, if I would have read this blog post before I did it, it would have saved me a month of time. So I think that if you're doing this, maybe we can share some lessons back to the community. Cool, so fast forward into today, current state. This is a much better diagram because I didn't do it. This is from the team. This is where we are today. It's definitely evolved from that beginning state. And I think like there's something really like lovely about that evolution for us. It started out very simple. A lot of that, the initial architecture, the initial assumptions, the initial choices they haven't been completely wrong yet. And there's been a very nice like evolution over time, rather than like having to rewrite whole swaths of the system or having to rewrite different services within it to deal with the scale that we're now at. And I count that as a success as an early stage founder. It means that we're not spending like great amount of engineering time thinking about rewriting our services or spending endless time like engineering for engineering's sake. I feel like we've developed a very practical service that's serving a lot of customer need and demand. One interesting thing is that the Postgres back job queue, which it's doing like hundreds and hundreds of millions of jobs, but we've actually replaced that now with SQS for obvious reasons. It's in the top right of this diagram now. So all of that delivery service now runs on SQS. And that's been really interesting because it's afforded us this ability to run per customer queues and get all of the things that we really wanted over the long term. And allows us to basically offer as an enterprise feature, like, hey, we can give you your own capacity in our cluster and things like that. So yeah, this is the current state of the system. Very proud of it. To talk about some of the challenges that we're facing in the future, we, as a notification service that deals with PII, basic data residency is becoming increasingly important to us and for our prospects and existing customers. So we're thinking about a multi-region deployment pretty soon. I feel like having bet on Terraform in the beginning, at least we're in a position where stamping out a new region should be, in theory, not terribly difficult, although there's going to be tons of hard engineering challenges there, I'm sure. We also have this imminent need to figure out horizontal scaling for some of our core data models, because we're on track to do billions of messages logged in a table a month. And again, facing the same kind of scaling challenges that I mentioned previously with some of the other logging tables that we have. I think that is probably a whole talk unto itself, thinking about like, how do you horizontally scale Postgres in today's era? There's tons of different services out there. So we're doing that set of comparisons pretty soon. So some interesting stuff there. Yeah, and then Redis is, Redis is like a bit of a single point of failure in our cluster right now. So something that's hot on our list. And then, a lot of the scaling and engineering team come along as well. Like, we need better deployments, like faster deployments, better rollbacks. There's a third thing that I didn't add. Yeah, it's like, yeah, there's a lot more work to be done. And I think like that's the nature of a complex system. It's like, it's never going to be done. So to give you some deep reflections on 3 years into this journey, yeah, I really like simple things. I like simple technology. I don't like AWS reference architecture diagrams, to say one thing. I think that like Postgres, Redis, a web server, and things like of that nature, you can get very, very far with that. I've always had this mantra as well since we started the company about we try and stay like ahead of our scaling concerns, but we're not trying to be caught up in them too much. So thinking about like what's the next evolution, like how can we forecast where we're going to go, and a lot of that is driven by sales data. What size of contract are we selling, how many messages per month are we thinking about we're going to be sending, and then trying to stay ahead of that curve as much as possible and keeping the team really close to that problem set. I would say, maybe this is not right, but like introducing new infra is kind of easy and was easy. Like we picked Kinesis and we were like, cool, Kinesis, shove it in the stack. Let's do that. And it basically took us like 1.5 years to mature that piece of infrastructure. And by that, I mean monitoring, I mean observability, I mean like thinking about like failed writes, I mean committing back to the driver that we're using because there's like very weird bugs in it at certain scale points. Yeah, so and we just picked up SQS and I had the same belief, which is like adding SQS is not terribly hard, and the engineer who led that project was adamant that we could have that done in a few months. But like, and we did do that, but maturing that piece of technology is a much larger and longer endeavor for us. And I feel like as your company scales, there's some law here that's like maturing the piece of infrastructure is also like correlated to the maturity of the company. Yeah, I feel very privileged that I have a wonderful team and they're all incredibly great at what they do. And I reference some blog posts inside of here, and they're written by the engineers who took on those challenges, like literally just me, like kind of nerd sniping engineers to say like, hey, let's fix this thing, and then they go and run at it. We have a really good blog post about our Postgres migration that we ran last year that we did with near enough zero downtime at a very large scale, relative sense for us. But it's a really good example of the kinds of things that the engineers on the team like love to take on, and the infrastructure challenges that they deal with on a daily basis. And then my last reflection as a CTO, yeah, there's this, like, I had that mantra at the beginning about like, hey, well, we want to keep optionality, right? And I don't think I realized like 3 years in what a cost that would be. And one of the engineers on the team said it to me very eloquently the other day. He said, well, if you just said we can go all in on AWS and we can use any service, it would be much easier for us because we don't have to think about this choice and drag it along and think about it in every comparison that we're doing. So yeah, and that idea about like, hey, we want to keep optionality because we might want to run on-prem or within our customer's cloud, whatever cloud that might be, hasn't proved out yet either. So that was a hypothesis that I might have been wrong about early. So and it has definite implications today. Yeah, that's all I have. So thank you for listening. Can I take a question?
Yeah, absolutely.
Oh, cool. Does anyone have any questions?
USC's too controversial.
Oh yeah, we're in USC State. Yeah. But yeah.
You mentioned something about serverless, that you said you were going to talk about later in the talk. Was that gone over later?
Oh, I guess that's the optionality question for me. It's like I've run a team that like leverage step functions and Lambda very heavily in the past, and it was one of like my early beliefs here that like we wanted to run real servers, and like especially when you think about like the degree of processing that a notification system like this does, it's kind of always on, right? Like we're always taking data, always like thinking about it. And I saw, yeah, Lambda, you know, on the sense that you're deploying Lambda functions, like you lose some of that optionality because you're very baked into the AWS ecosystem. Yes, there's serverless framework and stuff. I don't even know what's out there anymore. But yeah, it was one of the choices that I wanted to make sure that because I think you could sketch out this architecture and be like, it's SNS, Lambdas, sending things are really simple functions, but actually one of our competitors did that, and I think that it's locked them in a very interesting way, and I think Lambda gets expensive over time. So yeah. Yes.
What was your experience building up your team?
Great question. So the initial set of hires that we made were all generalists, and that was a really deliberate choice. So for the first 2 years of running NOC, we basically had 5 engineers, and they were all full stack engineers with no specialism. Well, you know, full stack in the sense that some people leaned a bit more front end, some people leaned a bit more back end. But we had no like deep ops experience on the team. I was fortunate that I had people that I worked with in the past come and join NOC to work on some of the problems that we described. And then we've only just separated out the team so that we have product engineers, platform engineers, and we have an SRE as well now. So the first kind of operations like infrastructure hire. So yeah, the experience of hiring Elixir engineers is very interesting because it's like a niche ecosystem, even though it's one of the more popular languages on the top 10 list right now. Obviously, it's towards the bottom. I think like I've always believed that like great software engineers are great software engineers, and like the language doesn't matter that much, and like actually people can learn these concepts relatively easily. So yeah, so I don't know if there's anything to say. Yeah.
The reason going to launch directly for feature flagging versus maybe consider building in-house, because feature flagging should be, you know, basic feature of the application.
Yeah, so did everyone hear that question? It was why launch Darkly over building feature flags in-house? So I mean, NOC is an API as a service, and I actually believe deeply in outsourcing the parts of your stack that don't matter. And I think I've built feature flags in-house before in a simplified way, had a dashboard that you can interact with. And that was never as good as what Launch Darkly offers today. And like Launch Darkly as a product is, you know, you can say what you want about feature flagging as a space, but them as a product, super reliable piece of infrastructure. They're an incredible team. They've done a very, very good job maturing that over a very large scale. So I'm definitely in favor of outsourcing more than I am in building in-house. So another example for us for that is we use WorkOS for all our like SAML and SSO integrations. Again, built that in-house before, didn't want to touch that. And then we use a company called Orb for all of our usage-based billing. Again, nothing I would like to build. Yeah. Yeah.
Related to feature flags, do you think you're going to continue this pattern where you're like enabling certain features of the runtime application versus splitting that out into a separate application?
I think there's parts that will naturally mature into services, and there'll be more boundaries here, like because we'll need more levers to pull and horizontal scalability and also scaling. So that hosty layer is right for splitting out into its own service, for instance. But I like the feature flagging pattern. I think it's kind of cool. Like it allows us to, we'd still do that, but then we could degrade certain customers' runtime or something like that as well. So I'm kind of in favor of keeping it around for now, but yeah.
How do you avoid code complexity with like cross dependencies or things?
The feature flagging code is silly simple because in Elixir, it's basically like, oh, is that your question or is that?
No, it's
Oh,
more
the
like you
service
have
boundary.
bigger code paths.
Yeah, sure. For us, yeah, that is a really good question, and we haven't figured that out. We use protobufs between services where we need to, so kind of thinking about it like that, but I'm not sure of the full answer there yet. Yeah. Anyone else?
I have one other question.
Yeah.
Do you think cloud credits made you a bit, like, not, you weren't sensitive enough to like what your real spend was gonna be?
Yes. Unequivocally, yeah, like, if you have $125,000 and you're thinking about growth, like you're not paying any attention to cloud costs, and to be honest, like, we think about our margins definitely as a like an API company, we report on them back to the board, but it's not something that we're spending a great deal of time on yet, because my belief is like, what you look at on the screen there, it's like, yeah, of course we can get the margins to be better. There's nothing like that crazy in the stack, right? Like it's like queues and EC2 containers, and we're not even buying like reserved instances or anything like that right now. So, but yeah, I guess to answer the original question, like, yeah, we were just whipping through it and we didn't care. But I think that's okay, right? I don't know. What do you think?
I think it leads to big database migrations.
Yeah,
Those are
probably.
painful.
Yeah.
But you have the flexibility to move in prem.
Yeah, I mean, I would say like moving away from Aurora would have been hard because it's Aurora Postgres is very good. But yeah, yeah, there's definitely equivalent things on GCP as well. So, yeah. Or yeah, moving it to our own KX stuff. So yeah, cool. That's it. Okay.
Thank you.
Thanks.